All right, and I had a question for the HL practice paper 1. This wonderful problem about the sheep. So we have 5 sheep in 6 pens, and there's some issues with the sheep where they can't hang out together. They can't play nice. So we know that Amber and Brownie are known to fight. Amber and Brownie. So, question A, completely separate from question B. Question A says each pen is large enough to contain 5 sheep. Amber and Brownie must not be placed in the same pen. Great. So, let's go through and try to find how many pens are possible for each of the sheep. I could put Amber anywhere. So, there's 6 possibilities for Amber. That leaves only 5 possibilities for Brownie because I can't put Brownie in the same sheep pen as Amber. What about Curly? Think about it for a second. Curly could hang out with Amber, Curly could hang out with Brownie, or Curly could get their own pen. And Daisy could get their own pen, and Eden could get their own pen. And really, I think that's about it. That we've got essentially 4 sheep can be placed wherever they want, and 1 sheep can't be placed with one of the other ones. So they have 5 other options. And I think that's all. Let me see if I'm missing something here. 6 options for Amber, 5 for Brownie. Yeah, I think that's it for the first one. Okay, so part B. Part B, each pen may contain only 1 sheep. Amber and Brownie must not be placed in pens which share a boundary. Okay. So, one way to approach this is to break it up into cases. And so, let's say that Amber is right here. Oops, let's get my pen marker again. Amber is right there. Then Brownie has 3 options. So, this is case number 1. Okay. If Amber is in the top left corner, then Brownie has 3 options. Curly needs to have their own thing. 2 pens are taken, but Curly could go. Let me be clear here. These are the 3 different options for Brownie, right? Now, Curly could go anywhere that's not already taken. So one of these is going to be taken. Let's just pretend that we put Brownie there. So then Curly has 4 spots remaining. Daisy has 3 spots remaining, and Eden has 2 spots remaining because they're each taking up 1 spot left over. So that's option number 1. Amber's in the top left corner. However, the picture is going to be the same if I put Amber in the top right corner. We're going to get the exact same calculation again. And the picture is going to be the same again if I put Amber in the bottom right corner or in the bottom left corner. So it looks like there's actually 4 groupings that fit this particular pattern. Okay, so I would say this is maybe cases 4, 3, 2, and 1. So there's only 2 other possibilities. So let's put Amber right here. Then the only 2 spots that Brownie could be would be here or here. So we'll call this case number 5. If we put Amber there, and then there are 2 spots for Brownie. Okay, let's say Brownie's there. Now there's 1, 2, 3, 4 empty spots for Curly, 3 spots for Daisy, 2 spots for Eden. Now, of course, this picture could just be reproduced by putting Amber right here. So that means that these, cases 5 and 6, are identical. So we're adding those up. What that looks like, a couple ways you could write that. What I notice is that both of them have a 4 factorial in them. Both of them have a 4 factorial. The first one has 4 times 3, and the other one has 2 times 2. So you could write your answer like that, or you could go a step further and say 4 factorial times 4 times 3 plus 1, because this right here is 4 times 1, or so I guess it's 4 factorial times 4 squared. I think that's a fine answer. If you really want to get weird, 4 to the third times 3 factorial. Why not? So there you go. Let me know if I made a mistake or if you have any questions, and I'm happy to help. Thank you.